Here is fleet failover for resilience and auto recovery against NIC and link flapping. For that, I'll first start a workload, a standard all reduced job between nodes 4 and 6. So we should be able to see the node throughput for nodes 4 and 6 shoot up. And as you can see, we detected that this workload throughput for nodes 4 and 6 is at 1.47 terabits per second. And we can look at this also at the network card level. So we're getting about 92 gigabits per second. These are 100 gigabits per second line rate network cards. I'm going to simulate the experiment first without our fleet failover. I'm going to simulate the NIC flap, and you can see NIC 1 is the one that I flapped, and you can see actually that NIC got grayed out and the throughput went down, meaning the workload crashed and the NIC was successfully detected as unhealthy. And you can see all of the network cards no longer carrying any meaningful traffic for this workload. At this point, we would need to fail over to a previous checkpoint, load all the weights, all the data back into the GPUs and start over. Now, if I bring back this network card to simulate a recovery, maybe I reseated this optical transceiver, reseated the cable, you can see that we successfully detected that NIC 1 is healthy. And I can show you why that is. You can see the probe traffic is back. You can see all the probes are back. You see the duration of the downtime for that network card that flapped. Despite the network card being back and healthy, the workload actually is not coming back. It's crashed. And this is the current behavior in all GPU clusters today that don't use FleetIQ. So here is an all reduced job that is running with fleet failover, FleetIQ fleet failover. I'm going to repeat the same experiment. So first I am running this workload with our module that auto recovers against NIC and link flapping. And as you can see, again, I'm getting 1.47 terabits per second in terms of throughput from each of these nodes. I'm going to again simulate a flap for NIC 1. So you will see that little square over there for NIC 1 go gray, where we are detecting successfully that network card flapped. Now you can see that we have a slightly degraded throughput here because we lost one network card. So the other remaining healthy network cards are doing double duty. They're also carrying NIC 1's load, and you can see NIC 1 in yellow there all the way down in throughput, and the remaining network cards doing this extra double duty, and that's why we have slightly reduced throughput. But the most important thing here is the workload didn't crash. It's actually continuing, so you don't have to fall back to a previous checkpoint. You don't have to start over the job. And if I simulate recovery of this network card from flapping, maybe I went to the data center, I reseated this cable. So the network card is successfully marked as healthy as green, as you can see on top. And you see the throughput actually is climbing back up. So we're successfully able to recover back to previous throughput. And you see all the network cards now back to doing normal duty and back to the original throughput that they have. Next, we are going to look at workload acceleration.